Moving on to specific review of fast charging technologies, I'd like to introduce Dr. Frank Loschman. He's the CEO of Business Development for Magus Group. Dr. Loschman has the ability to bring in a lot of automotive experience with over 20 years at Volkswagen. So he can wear several hats at this presentation and talk about integration, vehicle systems, charging. And I'd like to welcome him.
Yeah, ladies and gentlemen, thank you very much for the invitation to this fantastic meeting. As Mark said, I was some 20 years together with Volkswagen, and let me tell you a little bit of my history to come to the EV sector. Some 3 years ago, I was in India and in China, and I've seen a lot of development in terms of EV technology, more than in Germany, for example. And because of that, I decided to go over to my own business, and I found a small company in Slovenia. And these guys are very deep in research and development in terms of EV technologies. It's not only fast charging, it's also EV components like motors, like complete technology and so on. And because of that, we created, let's say, a network out of a German company, an Italian company, and this Slovenian company called Magus for, let's say, future sustainable business. We've seen a little bit about the e-cars in the other presentations, and what is really interesting for me, like in, let's say, a mechanical and automotive guy, Anthony, what you said, it's really interesting to see the change in terms of automotive guys. Some years ago we talked about electricity like something else, but now we found a lot of sweet spots where we can work together in terms of electrical technologies, but also wireless technologies. And I think there are some really nice things what we can do in future together. But first, let's ask the customer. In our first presentation, Ingo told us the EV technology is driven by engineers, not by customers. But we all have to accept the engineers don't buy the cars. Because of that, we have to think about what we can do to have some influence to the customers to, in future, buy our technologies. We have some problems like weight will be solved at the moment by different technologies in terms of lightweight, for example, the BMW, what they're using, the speed, often asked, but not loud from the customer. It's also solvable. Overall efficiency. I don't know if you know this. This is a small car called Volpe. Will be coming to the market, I think next year. Created by Zagato in terms of design. But it's also very interesting because of size, all over efficiency. It's really a good idea to do something like that. And it's not Renault in that case. I think in terms of comfort, we have seen also one picture of the Fisker Karma before. It's solvable at the moment, but we have some points to see, perhaps together, in terms of infrastructure, service net. How does it work in future? Another topic we have seen in one slide, the lifetime of the battery can be some 5 years, perhaps some 8 years. I don't believe in that at the moment. I think we have to accept that we have to do something for the battery, but the reality at the moment is 2 years. We have big problems with the battery and the battery load time. The battery load time in between 8 hours down to 3 hours at the moment. There are some developments in the right directions. What we have to solve in the future is something for our customers that they can load the battery in a way what is acceptable, because this is a sales reason. The customer will not buy a car where he have the chance to stay on the street and don't have the chance to fill his battery again in times of 3 hours. Because of that, the customer compares. He compares at the moment gasoline tank, and this is what I did today, 2 times. A stop at the station after 600 to 800 kilometers needs some 0.5 minutes. Taking the pistol, filling the tank, 2 minutes, run to the check for to pay, some 3 minutes normally. Start again, some 0.5 minutes. That means 6 minutes to fill a car completely with gasoline. Let's see the same situation for an electrical car now. Stop at the station after 100 or 200 kilometers. It's the same, taking the pistol, filling the battery, it's 360 minutes. And we have to do it 4 times to get the same efficiency. That means 240 times more time to fill the car. And that's what the customer at the moment is looking at. And so what we did, like Magus Group, we thought about this topic and thought about how to solve this situation. There are some ideas with a battery management system to put in as much as power capacity in the battery as possible. But as you know, the heating problem will lower down the lifetime of the battery and so on. So we thought about the fast charging technologies, and my guys are together with me to discuss with you a little bit more in deep, if you're interested. What can we do in terms of overheating? The main problem is not to exceed these 45 degrees centigrade, to get a lifetime which is really 5 years or perhaps 7 years. A special technology has to be applied to charge the battery with a high current and keep the safe temperature zone. The life cycle will go up automatically. Next point, I think we have seen a lot of possibilities to do it, public places for the availability, shopping centers and other sectors, and the safety. We have also seen some technologies which are very interesting in my point of view, especially these wireless connectivity. It's also interesting in that case. To see the situation that the real today's technology means we have 0.1 times the capacity up to 1 the capacity. That means loading times in between some, let's say, 8 hours to 3 hours, something like that. Development is in direction 3 times the capacity to load the battery. Our technology will lead us to 6 times the capacity. That means the battery is full after some 50 minutes. Our solution at the moment is a peak pulse current charging. What we had like prototype, done like prototype at the moment. That means we fill with a maximum of 100 ampere, for example, and leave the battery alone for some microseconds and to do it again and again. So we have the possibility, this is the measured current measured using an oscilloscope in the same way. This is a block diagram, how to do it. The difference in between this charger made by Magus, by the Magus group, is finally the pulse indicator in the middle, 0.2. And on the other hand, you see the reality, what we did like prototype at the moment. What was also interesting for us, we have 2 types of diagrams. The fast charging performance in between 40 minutes and the standard charger performance in between 112 minutes with a nearly same solution. The only major difference is also the temperature, which is finally in a better position with a maximum of 45 degrees at the moment. The discharging diagram, as you can see here, the fast charge battery also have a better capacity use in terms of discharging than the standard charge battery. So in our first steps, we have seen a very good situation in terms of enlarge the lifetime of the battery. And that's what you can see here. The number of cycles will increase with our technology. The battery charger is patented, and I think we solved in terms of heat management the overvoltage. We solved at the moment, in our point of view, the battery temperature with a maximum, and the overcharging of the battery is also impossible because of the damages of the battery will be eliminated. The system is patented in the US and also in Slovenia at the moment. And we would go further together with partners in the future in terms of sustainable, ecologic, efficient product for the automotive industry. And our idea is to have finally a 50 minutes EV charging standard in terms of pulse charging systems. As we've seen the reality, future development of fast charging power stations for 10 to 30 kilowatt hours lithium batteries with a 100 kilowatt power station with a maximum of 500 volts and 200 amperes pulsed. And so we can also optimize it. We have two stations to use the same wire for both systems. And the real charging time we will see in reality with the development phase which follows now. This could be our charger models, a smaller one for public garages, and the bigger one, as we have seen, fast charging power stations, as we have seen in different presentations now. And I think with these two possibilities, we are able to optimize the charging time relatively fast, and also the lifetime of the battery. Next steps. We will finalize the development of the fast charging systems, I think this and the next year, and we would like to establish our company in the automotive sector or the surrounding sector and bring the technology to the market at the end of this year and the next year. At the moment we have an integrated prototype, and I would like to ask you if it's your choice and your opportunity, what you see, what we can perhaps do in terms of cooperation together to bring a new product relatively fast in the market, not to talk about research, to talk about something what is a need for the customer to accept the load time for the battery. What we did, we combined a network together with 3 companies. The Magus Group as main topic for the technology development and project management, in that case, an Italian company which is called SPM for the engineering and design and business development we are doing with the System Group out of Germany in terms of business development. And I think this network thinking is the most important thinking for us in the future, to bring all these topics together to solve the future problems. Our vision? I don't believe at the moment we are able to solve the problem in terms of gasoline tank in about 6 minutes to fill a complete electrical car, but 16 minutes is possible in the complete range. That means finally, because the battery is up to 200 kilometers, it's 10 times more at the moment than to fill a gasoline station. A big step from 240 times, but I think a little bit to do also with the battery technology. Thank you very much.